Alright, since we have understood the concept of packages and modules, let's import a standard package in Python called as the math, the package which is math, and we can use that, and let's understand it in more detail. So I'll just open a new file, and we can name it as, you can save it anywhere. For now I'll just save it in IoT Python itself. I'm going to save it as, using math. Okay, so that's a package or a library which is given to us for use. Okay, we can just import the math package, and we can just use that, and of course use the methods of the math by saying math.sign, and sign can just return to us, let's say math.sign of 23. And now if I run things, it's gonna be of course 23, which means it is taking it in radians, right? So is it possible, sir, to change a value which is there in degrees? I want to find out sine of 60, sine of 60 degrees, sine of 60 degrees. So is it possible for me to do that? Okay, sine of 60 degrees, is it possible for me to do that? Okay, it is possible for me to find out sine of 60, but I can't do it directly because over here this 60 is taken as radians. So I need to convert this 60 degrees into radians and then put it up here. So the way of doing it, one of the ways of doing converting degrees into radians will be something like this, by doing, say for example, angle in degrees is always, so angle in degrees, if I have to convert it into angle in radians, okay, it has to be converted by multiplying it by pi, that is 3.14. you have to multiply it by pi, and you have to divide it by 180, that is 180 degrees. So that's how you get it in radians. So if I do math.sign, if I take my degrees, my angle in degrees is 60, I convert it into radians, and then that I give it to math.sign of r. And now if I do this, it says, oh, pi is not defined. So I need to have pi. It's already there in the math library. I can access it by saying math.pi. Okay, so if I run this out, it says 0.86, 60 degree, sine of 60 is root 3 by 2, that is 0.8. If I do it 30, okay, I can do it like this. Okay, that is 0.5, that's half. But I didn't want, this is a very crude way of doing it, right? Angle in degrees multiplied by pi divided by 180. So is that possible that you can do something else? Yes, I can. Instead of doing this particular procedure, there is another procedure of saying math dot. Okay, you can do a control space to get what are the functions or the methods that a math class has. You can see there is something called as math.radians, which means I just need to give the degree in that. It will convert it to radians and give it to me. So I can say math.radians degree, function fi, enter. Yes, it does the same thing for me. I can even say 60 here and save it, and of course run it. It'll have 0.866. So this is how I can use the math functions to do a particular task. Okay, so now if I say I want to, in this particular file, I am having my own function. So I'm having my own function. The function is something like, I'm just creating my own function, say def, creating a function called as factorial, which takes in a number. Okay, and it returns for me the factorial of a number. So it returns for me the factorial of the number. But how do you calculate the factorial of the number? You can calculate using the math.fact. Okay, or math.control space. Have a look, is there a function or a method for factorial? Yes, there is factorial, and I just need to pass the number. you will anytime get the math.factorial number that I can take it into f and return f. Right, I can save this. I don't need to have this degree and all this stuff for now, and this is going to be my function, and this is my function which I'm going to save, and I'm going to run it. So it's defined, that function is defined for me. I can call that with any particular value. Let's say fac of 5 is going to be 120, fac of 10 is going to be nice 362 8800. So that's how it's going to be. Now let's say I have another file, and I say save it as something else. Let's say math1 or something like that. We're just gonna save it for now, and then I'm now going to import the file that is using _math. Okay, if I import that, okay, let's say, I'll just print something here for now so that you can see if it is working or not. Say hello from using math. Okay, so let's see if that prints up here when I run the other file. So if I run this file, it says hello from using math. So I have not written anything here, it's written in the other one, right? You remember what I taught in the last class, so I can just say in using math. So if I don't want this to be printed in the other side, I can put this in if __name _ equal to _ main _ and then say colon and then print it out. Save. The same thing. So now if I import this and if I run this code, it is imported using math, but it will not print the other one because it is only for that particular file. Alright, now we go back to this file, and now I want to use this fac of this, so I'm going to say import using math. Of course, now if I just want to say print, I just want to use fac that is a function of this particular module. If I say print fac of 10, and I do a function fi, it will say, hey, fac is not defined. Fac is not defined in your program. Of course, it is not defined in your program. It is defined in another module. That does not mean you can use it without saying the module name using _math.fac, and then run it out, and you can see, yes, you got it, right? So now many a times your package is so big and you want to use that particular package name .fac, and you might have to use it a couple of times, many number of times you might have to use it. It's not that easy to keep using things like this. So what you do is, instead of saying import using _math just like that, you can also say as a particular value. You can use it as, let's say you use it as, just say a small m. Save it, and now instead of using math, you can just call it as small m. Save it, function fi. That's it. So this is how you can import this class but use it with a smaller variable name or with a smaller name. Is that clear? Okay, now I come back to using math, and if you remember, I'm just going to go back to the time when I was printing the sine, right? Yeah, so I have my sine being printed, okay, and my radians being calculated, right? So my sine is being printed by this particular function. That's because so I need to call the module name .sine if I do an import math. But if I write this in a different way, if I say something like this, from math, that is from math library, I import only sine and radians. If I import only them, I don't need to use this math.radians because I have imported these two functions into my program. I have imported these two methods into my program from math. So now this radians and sine is directly available for me in this program, which means I don't need to call it with math.radians. It is now there available for me in this program. I can just say r is radians of t or sine of r. That's it, and you get this as 0.8660254. So hope you understood the concept that we've been learning, that is d is equal to, so this is how we can import particular files and do our stuff. Hope you are in sync up till now, and how to use packages. Get your hands to the working, and we hope to see you in the next lecture. Thank you. Have a nice time.